now on, all the upcoming videos of this series will be available early for the members of the channel. That means that if you have the membership, you will get access to the videos before they will be released to the public. It's a great way to stay ahead and support the channel and dive into the content as soon as it's ready. Thank you so much for all the support, and as always, happy coding.
Hello and welcome back to my YouTube channel, and this is going to be the next part of our Kotlin Essential series, that is part of our Compose Multiplatform series. Okay, so in the previous video we covered classes and constructors, and in this video we will try to cover collections. Collections are a very core element of programming, and we use it like almost every place when working on apps. So in this video, we will be covering collections. And when we talk about collection, the first question arises is that what is collection? A collection is basically something that let you store similar kind of data in one place and then let you manipulate and you know do some processing on that. So that's basically something some vague definition of collection. Now, when we talk about collection in generic or like in data structures, a collection is something like I explained, having multiple elements or no elements, or like kind of a container that can contain multiple or no elements in it is called as collection. But when we talk about collection in Kotlin, like there is a specific interface that we used in Kotlin that is slightly different. So like when we talk like if there is like any sort of interview question or anything, you need to make sure to to have an explanation for both of them. Okay, now, I'll try to explain something before jumping into the code of how collection works, or like how we can use it, or like what kind of operator there are that we can use to manipulate the data inside it and process the data inside it. So basically, the first thing that I would want to explain over here is the mutable and immutable. If you remember, we've discussed mutable and immutable in a way. If you remember about war and sorry, that was be yeah. If you remember about war and wall, we discussed something like what is a read-only thing and a one-time value that you can assign, and the second thing is the war, which can be changed. So this was some explanation, and I basically that we will take that same similar explanation in this. So so basically what we do is that in normal variable scenario, what we do is that we create a variable and then we assign a value into this. So basically we know that if it's a war, it can we can assign a value later on into that as well. But when we talk about wall, when we assign something, we know that we cannot change the value of it, right? But with collection, the mutability and immutability of the collection is slightly different. I'll show you exactly what it is, but the first thing that I wanted to show you that there are two different kind of collections. Either they are mutable or they are immutable. Okay, now we'll start with the very basic thing. So basically, everything in collection in Kotlin, there are like different kind of collection like list and sets. They are supposed to extend an iterable. So iterable is basically an interface that contain a couple of functions or like functionalities that is basically implemented by the collection part of it. And now when I talk about collection, this is basically the collection interface that we use. Okay, so the this is basically the immutable structure that I'm gonna go through. So this is the immutable collections. Okay, no, so first thing that comes like if we go to the complete background of it, the first interface that we have is basically an iterable, and the iterable is basically the iterable is implemented by a collection class, a collection interface. A collection interface this time it's a Java collection interface that comes from java.utils. It's not the collection that we use in the when we talk about data structures or like computer science. Okay, now that's collection. The third thing that comes after that is that there are different kind of collections. For example, we have lists, and along with that we also have sets. Okay, So this is basically something that we have. Now, when we talk about mutables, what we do have is that, uh, again, iterable should be there, but in between iterable there is one more thing that is called mutable iterable. That's again an interface. And over here now what we have is that we have mutable collection. And once we have all these things, the mutable collection can now contains mutable list and mutable sets. So this is something, there are two different kind of collections. Now I'll try to explain one more thing that is basically a specialized collection. Like when we talk about data structure, it's basically part of the collection category. But in Kotlin, it is basically handled specially because the structure or the way it contains data it's quite different than this one. So for that, what we have is that we have maps. So map in Kotlin or Java is basically again some a specialized collection, because it is slightly different than how we have these values or these implementations in it. And this map contains basically two things. It's either maps for when it comes to immutable, and then we have mutable maps when it comes to mutable collection. Okay, so these are the things that we will be covering in this video. We will be like, I'll try to explain how immutable list works, how we can assign like different value different how we can create a variable of mutables and then add values into it and retrieve values from them. And then when it comes to immutable, how we can process them. So we will be testing out a smaller chunk of these, and then along with that, we will be testing the maps as well. This is the basic structure of how the collections are in Kotlin. So now the next thing, or like now, let me just start with the very basic thing. We'll start with the first one, that is list. A very common one. We use it all the time in Kotlin and in programming. So we'll start with list. And when we talk about list, I'll start with immutable one. Okay. So I create wall list is equals to list of, and then I add some value. So let's say I add fk code Furkan and what else, YouTube. So let's say I have created this list, and you can see I added this as wall. Now I added a wall, and you might think that okay, this might be the immutable thing. If I add it as war, it becomes immutable. But no, this is not the way, or this is not the mutability or immutability of how collection works. So I'll keep it list. And now the immutability of this thing is that if we try to call list dot get at index 0, which means that it will get me an index 0 value, whatever it is. Okay, and then I'll print that println v. Okay, now I just created this simple list, and we try to fetch one value from there and assign it into the immutable variable, and then print that out. And you can see that it will print it out. You can see this fk is basically now printed. Now let me try to add one more value into the list. So how would we do that? I'll say wall, sorry, not wall, list dot add, and let's add one more thing, and that is basically be something. What should we add? Let's add Kotlin into this. Okay, so now I'm trying to add one element into this list that's in an existing list, and when I try to do that, you will see that it will not be able to add it because it's saying the reference is not available. Like there's no functionality with the name add, which means you cannot add anything into this list. Okay, and that is the immutability of it. You cannot add the value into it or change the value of these. Okay, so like we have also a replace function normally that we use. You will not be able to use replace as well, because it will say that there is no function, no such function that can be used over here. But let me just add this, keep it this, and rather than using list of, what we do is that we use mutable list of. Now again, you'll see that the wall is there, it's like there. The wall list is the immutability of this variable, okay? But the mutability of the list or the collection comes from this thing. Now I'm using mutable list of, and now you will see that I'll be able to add, add it, add Kotlin into the list, and then rather than printing v, what I'm going to do is that I'm going to print the list before and after, okay? So that we know if the value was actually added to the list and if there was any issue with that. Now let's just run this, and now when I run this, you will see that initially it had these 4 values and now it has these 5 values. It doesn't matter if it's a wall or a war. Again, I'm explaining, I'm basically, because this becomes so much confusing. This doesn't matter, this is only related to the left part of it. So the anything, we cannot change the list. Now let's say if I use list is equals to mutable list of, and I say a b. Now it will not work. So basically the immutability of this specific variable is there because this is wall. But if I change it to var, you will see that it will run without any issue, without any problem, because now I basically made this variable. But the actual value, the list, or like the kind of memory that was assigned to it, the mutability of that depends on this, okay? So that is the one of the like confusing part, where sometime we basically mix up the wall list with the mutability or like immutability of the list. The mutability and immutability of the list depends on how we create this. Like if I add a mutable list of, which means now this is going to be changed, but if I add a list of, this becomes that we cannot add any item into list or remove any item from the list, and this will basically define the mutability of the list. So this is how basically lists are. Now what is list? We saw a list is basically something that you have something in sequential order, okay? So a list that contains a sequential order. Now the next thing that I'm going to explain is sets. When it comes to set is basically the generic mathematical terminology that we use for set, and that is basically something or like a list, or that is like unique, distinct kind of sets, value, distinct kind of list, okay? So basically, for example, I create wall items is equals to set of, and I call it a, b, c, a, d, b. Okay, so let's say I create something like this. What it will do is that it will just keep the first element, and then the rest, if it comes next time, it will remove it. So we have a, b, c, a, d, b. If I make a set of it, this, what it will do is that it will remove this a and this b, and it will just give me a, b, c, d. But if it were list, it would like keep everything, and I'll show you now. So now I'm going to say println items. Now let's just run this, and when I run this, you will see that it printed a, b, c, d. Let's do the same thing, like just use the let's copy this the whole and call it a list, and let's print a list of a, b, c, d. Okay, and over here what I'm going to do is that I'm going to print ln list first and then items second. So when I print this, you will see that the list contained, like list showed me the duplication in it as well, but set was like very specific, and it doesn't matter if like later on, if let's say I make it a mutable set, and I later on add, let's add items dot add b, and I'm gonna do it for like so many times, okay? Just as for an explanation. So what I did, I like added b for like 1, 2, 3, 4, 5 times. And again, if I run it, you will see that it will not add it again, and like it will keep on ignoring that. So this is basically how the sets are. That's the major thing. So let's say if you have, some sort of data or some sort of mechanism where you don't need duplication in your data. For that, what you're gonna do is that you're gonna use set. Okay, so now the third thing that comes is, okay, so I thought I missed that, unique values or unique list. Now the third one is maps. Maps is kind of a dictionary. If you have ever seen a dictionary is something that basically where that lets you, find a word and other meanings or synonyms of that. So that's the exact same thing a maps does. Is basically a map gives you a key through which you can find a value. So a key value pair based setup, uh, where you have keys, you can access the values based on the key. So that's something. Okay, now in maps, what I'm gonna do is we'll create wall map is equals to map of. Now over here, as I said, you need to define a key and value. And a key can be of any type, a value can be of any type. It doesn't matter, like if you are using key as a string, we can define that as well over here, like a string and integer. So if you use string and integer, this means that the key is going to be a string and an integer is going to be an integer value. Okay. So, sorry, the value is going to be an integer value. And for that, what you're going to do is that you're going to say a, a, a to 1. That's one element. Then we'll be saying b to 2 and similar like c to 3. And now when we print that, you will see that it will basically show you the map of a1 b equals to 2 and c equals to 3. So basically over here you can see something like this. Now uh, again, if you later on want to add any element into this, for example, you want to say of map of d is equals to 34, for example, you try to do it, it will not run, it will fail, it will say there is no set operator for that. But if you use mutable map of and you run this, you will see that now it can add this new value into this. And that's exactly the difference between mutable and immutable, because you can use these kind of things with maps. And if you try to fetch any value from map, you need to define the key like I did for that. So let's say I want to see what is the value of map of b, like the value of b in the dictionary. So what I'm going to do, I'm going to say println map of b, you know and if I run this, just remove this map list from here, and now if we run this, you will see that it will give me the value of b, which is 2. Same goes if we try c, it will give me 3. So that's basically how map works, and that is going to be, what do we see? What do we say? It is called key value, based. Okay, so these are some of the collections that we use. Now we will talk a little bit of operators and how operators, like how we can use operators on list, how we can use operators on maps, how can we use operators on list. So we'll start with the list. I'm going to say wall list is equals to list of, and we'll use a couple of name into this. Okay, I think 4 should be enough. Now I'll basically do some sort of operations on this list, and we'll see how it works. And you can use them in your code as well. Let's say you want a specific index. You know the index of which index you want to take. In list, basically indexes are something where the values are basically stored. It starts with 0 and it goes up to the size. So for Khan, the index is going to be 0, Ahmad is 1, Rahul 2, and Irfan is 3. Okay. Now let me print something. Print ln list of 0, which means now it will be giving me the first index or 0th index. Now the next thing that you can do with list is that you can call first. The first in list of 0 is pretty much similar. But the first one is basically a more you know kind of approach, and I'll explain why. Is that if you try these two and the item is not available, it will crash if the list is empty. But I'll explain. There is one more way to get make sure that it doesn't crash. But we'll run this and you'll see what happens. So basically, when I run this, you will see that you got Furkan and Furkan for both of them. Now let's say we remove this and I run this. So when we remove this, you can say that basically you are trying to get something out of list. Okay, let me just make it a little bit easier for them. It's basically trying to access a type which is not available there. Now you see when I added this list string, which it's basically just defining that what kind of list it is. It's no worries. I'll explain what generics are. But you see it says index out of bound exception, which means that empty list doesn't contain index 0, and it will help, like it will be happening for both of them. Let me try this one as well. When you try with this one, it will also be saying that the list is empty and you're trying to access the first element which is not available there. Okay, now this was the problem. Now what I'm gonna do is that I'm gonna add back those values, or let's just revert everything for now. Now we have this thing. I'm gonna add a comment to this, and rather than using first, I'm gonna use first or null. Now this time when we run this, what it will do is that it will try if the value is available, fine. If not, what it will do is that it will return a null. And this way the app is not going to crash. Okay? And this is how basically like this is one of the operator that you there are so many other operators as well that we can use. And now let me just go back to the list that we have, and I'll show you some of the other operations. Like there are so many, but I'm just gonna give you a little bit one. The next operator that I'm gonna use, list dot last, and if you run this, it will give you the last element of the list. You can see that now we are getting Irfan for this. And let's use one more, that is going to be get or null. Again, for first you can also have first or null. For last you can also have last or null. And now for get you can also have a get, you know list dot get, sorry, list dot get. And you can define the index of what index you want. Let's say I want to index get 10, and now when I try to get 10, it will fail, because you see it says the index 10 is out of bound. The total length is 4. I'm trying to access the 10 index. So for that you can always use get or null, like you used first or null. So again, that is something that you can use. What else? You can also have some sort of conditional thing as well. For example, you can say list dot contains, if the list contains Furkan, what it will do is that it will return a true or false. And now if you run this, you will see that it will be returning a true. It's showing that the value is available. Now let's say we add FSF and we try running this time it will be false. Okay, that's something. Now there's one, like there are some functionality that you can use. For example, println list dot is empty. Now this is a function that you can use when trying to check if the list that you are having is basically empty or not. And that's something that it will give you. You can also have is not empty as well. So we have like both of them. You can use either one depending on your need. There's one more thing that is, again, that's interesting, and that is going to be print ln list dot indices. Now this is interesting. When I print this, you will see what does this mean. This gives the range. If you remember in the loops, when we implemented the loop, we had a for loop that was using index, that like the ranges. And if you want something like that, what you can do is that you can use that. And I'm going to use the indices now for this, and I'm going to say for I in list dot indices. Okay, and now I'm going to say print ln list dot get or null, and I'm going to pass I. So what I did over here in this loop is that I used I, and I used this property from the list that basically gives me the range, and I use that range to print the value. And now if we run this, the first items are going to be the process, and then it will give me the list that I printed over here. And now that we have done the loop, there is one more loop that you can also use without, having to worry about the indexing and printing the element. If you want the exact name for that list, you can also get that. And for that, I'm going to say item in list. This is basically for each loop, as we have explained already, but I'm just repeating it over here. And that is also going to be giving you the uh, value. This was giving me an index, and then based on index I'm getting get or null, but over here it will be giving me the item, the actual value from the list. And let's say we add some sort of logs. Okay, and I'm gonna add this as for each loop. Okay, now when you run this, we'll see what happens. That for each loop also contain like print something similar to what we had. Now let's say we want to do some sort of other kind of processing on this. For example, I want to add something by end of each of these values. How do we do that? There's like two different things. Let me just do one more thing. I'm going to say wall items is equals to list of, and rather than having these, I'm going to say 1 2 3 4 5 6 7 8 9. So this is a list that I have. First thing that I'm going to do is that I want to have a multiplier of all these values. So if you want a multiplier of all these values, what you're going to do, that I'm going to say wall doubled. Okay, and then I'm going to say items dot map. Now this map operator, what it does is that it basically takes each item from there, from this list, each item, and then over here whatever expression that you define, it will do that expression and then create a list of that. And that's exactly what we are going to do, right? So I'm going to say it is basically part of this map. It links to the item that it returns. And since I said that I'm going to multiply each by 2, and now I'm going to say double print ln double. Okay, for temporarily I'm just getting rid of this because we've already explained this. Now let me just run this and you will see the actual list was 1 2 3 4 5 6 7 8 9, but the double list was now 2 4 6 8 10 12 14 16. And this is basically the benefit of map. And it's not just to this, you can do any kind of operation on this. It doesn't matter. I basically just give you an example. You can do anything. You can do subtraction, multiplication, and if your class is different, like if you are using custom classes, you can do custom implementation on that. Now let's say we want to have even numbers in this list. So I'm going to say wall even numbers. And then for that, I'm going to use the filter operator. So I'm going to say items dot filter. Now in this filter, again, you have IT. That IT depends to this one. And now we know that even numbers are like modded by 2 if they are equally to 0. This means that they are even numbers. So I'm going to say print ln, and I'm going to say even even numbers are even numbers. Now, let me just run this and you will see you got the even numbers like 2 4 6 8 from this list, right? And sometime like even like, let me just do one more thing. For example, what we are going to do is that I'm going to use the even numbers from this one, from this list, not this one, but this one. So to do that, what I'm going to do is that I'm going to say items dot map. So in the map, I said it multiply by, where is the multiplier? Okay, multiplier by 3, and then you filter it by even numbers. So what we did initially is that I added one operator and then I added another operator later on. And if I run this, you will see that first it will be multiplying by 2, and then second it will basically give me a list of this. Right, so this is something that you can do. There are like so many other operators. If I keep on explaining, this video will become hours long. But you can explore that. You can try exploring. We're like playing around with this. One more thing I can maybe show you is that item is equal to, that is fine. So I'm going to say items dot find, and over here you can have some sort of like condition to add, and it will give you the values. So let's say I want to say if it is greater than 5, you can give me the value. And now if we do that and I print this item over here, we don't need the double, so you just get rid of that double for now. Now let me just run this. You will see that it gave me the first element that it's basically available. But it's not just that, you can also have find last as well, for example. So if you use find last, what it will do is that it will give you the last element that is available, greater than that. And if you want a whole list, what you can do is that you can again use filter it is greater than 5. And now if you run this, you will see you will give it will give you a list of 6, 7, 8, 9. So like there are like so many these kind of things that you can use with this. And now let's just use the same thing, like the same structure that we had with sets. We did all this with list, right? Now if we try to do with list, you will see that it will work with set as well. And because they have the same structure and same kind of things, and if you run this, you will see even the even number one will also be working with sets as well. Now the question is, will they work with a map? Now let's just find out with map, because the map is quite different, and it doesn't contain the similar approach and some similar values from this. And now what I'm going to do is that I'm going to create a map, and we'll see what properties we can use on map. So I'm going to say map, and the wall map is equals to map of, and over here you will say a1 b, oh, it's going to be a to 1, b to 2, c to 3, and let's use d to 4. So this is a map. Okay, now with this, the problem that you will face is that, let's say I wanna do wall up is equals to map, and then over here I'm going to say it dot value, because it is basically this whole structure and the value is basically this one. So I just want that value and multiply by 2. So when I do that, and let me just print both of them, I'm going to say print ln map, and over here I'm going to say print print ln up. Okay, and we run this. Okay, let's just try this again. Now over here you will see that the first one was map and the second one became a list. And that is basically why, because the map just took this one and then based on that it basically created these values. Now the next thing that I'm going to give you is that this filter. So now when it comes to filter, what it does is that it goes through this whole thing, and a filter you those values. So basically I'm going to say if it dot value is greater than 2, you can filter those. And this time when I print it, you will see that now we will get the map rather than the list. With the map filter, or with the map operator, what it does is that it basically takes that specific chunk of value and then create a list of that. But with filter, you can see that it basically gave me a specific thing. And then similar, like say if I try to like print find, and you will see that the find is not available. So basically there are like so many operators, some you might find, some you might not find. Now let me just try find id dot value, that it basically is not able to find, like have that find operator. And for that you need to look through the map and see which operators are available and which one are not. So basically, as I mentioned, map is a specialized collection in Kotlin and Java, and it's been handled separately than sets and list. And the reason is that the way it is approached. So, like in all the list and the sets, we have key. We don't have key values, but over here we have um, key and value, which basically make it slightly different to go with it. And map is basically used for a very different stuff. So that's why you see something like this in map. But what if you want to do some sort of the map functionality on map? How do we do that? So to do that, what you will do is that you say wall up as I did, and I'm going to say map, sorry, map dot map values. Let's say map values, and over here I'm going to say it dot values is equals to 2. Okay. Now when you run this time, oh sorry, we need to print as well, print ln up. Now when I run this, you will see that now basically it kept it as map and updated the value. Previously when we used map, you saw that it basically gave me a list, but this time you can do something like this. And let's say you want to change the keys. For that you can say map dot map keys, right? And over here you can define that what you want to do with the keys, the key plus it dot value. Let's say I do something like this, and then rather than printing up, I'm gonna print k, and let's just print it. And you can see that now it basically merged the a1 b2 c3 and d4. And that's basically how you can use uh, some specific operator that are available. There are so many other operators that you can use as well, but yeah. And now, one last thing that you can do is that you can always access the entries. You can also always access the keys, and you can always access the values. And I'll show you what I mean by that. I'm going to say println map dot entries, and I'm going to say println map dot keys, and I'm going to say no, sorry, excuse me, print. And then I'm going to say println map dot values. Okay. I'm going to get rid of this and these two as well. Now, let's just run this. Come on. Okay, let's just try this. Now, we have println 1, println 2, and println. So basically, the first one in entries, it gave the similar but as a list. You can see it gives you similar thing, but yeah, it gives you this whole as a list. Now, the next one that it gave you was keys, and the last one was values. And now, if you ever try to find, or you want to see some contain, so you can always get the values and then add all those operators that we had, like the filter one, or let's say find one. You can always add these kind of things in this as well. But yeah, that's something that I wanted. So yeah, that's I think pretty much for this video. I hope you understood the list, sets, and maps. And I'll see you in the next video. So till then, happy coding. Bye.
Thank you so much for watching the video. If you found this tutorial helpful, don't forget to like, subscribe, and press the bell icon so you don't forget any update. If you got any question, you can join my Discord server. The link is in the description. Also, for quick updates and tips, you can follow me on Instagram. Until next time, keep learning, keep developing. Bye.